Hello everybody, how's everybody doing? I hope you're doing fine. We have an exciting day today in physics. Sad day for mathematical physics, terrible day for quantum mechanics, for general relativity, but great day for physics. Okay, we're going to be talking about a couple subjects that a lot of people are interested in. Okay, they don't concern physics that much, but somehow the mathematicians managed to bring these things into physics, and so we have to deal with them, because they claim that physics can tell us something about it, and that is about free will and determinism. So here's a question for you. Do you think you have free will? I mean, do you think you can do anything you want, or do you think someone's pulling your strings from above, or that makes you walk in a certain direction, makes you do certain things? You think you're being guided by some kind of invisible hand or something? The interesting thing about this question is that the mathematicians conclude that it's both. You have free will, and there's also determinism. You're being pulled by the puppeteer, okay? But you do have free will. You're a cartoon character in a cartoon. You're Bugs Bunny or whatever. And here's the script writer. He said, okay, Bugs Bunny should do this, should do that, then he should move this way, he should say this. And that's what he lays out, that's what he programs, that's what he draws and everything. He's got it all set up. And it turns out that the cartoon character, Bugs Bunny, says, hey, I'm not going to say what's up, Doc, anymore. And he goes off the screen or does something else that you did not program or put in there. Now that's scary. When the cartoon character has life of its own, it's dangerous. It means, probably you've been overdoing it on the booze or something. Imagine God, he programs everything. You got to do something according to how he already programmed it for the next gazillions of years. And it turns out that you don't follow the script. He's already laid it out. He said, look, I've got all the frames of the film for the rest of eternity. It's there. All you're doing is walking on footsteps, right? Because he knows the future. And it turns out that he doesn't know it because you decided not to walk those footsteps. You did something else, and Joey did something else, and his neighbor did something else. So everybody does something else than what God planned, which means that he did not know what was going to happen. And so this issue of the fight between determinism and free will, it's been around for at least 2,000 years, and probably even more. I think even the Greeks with their gods, they probably pondered that. Maybe even the Persians, Sumerians and so on, they probably dealt with these issues as well. It probably came to their mind, these issues. And here's a list of some of the people who dealt with the issues. It starts with the Bible. It says, for whom he did foreknow, he also did predestinate. Moreover, whom he did predestinate, them he also called. And so for those people who believe literally in the word of the Bible, God apparently predestinates every person, meaning he already knows what's going to happen in the future. And that is consistent with being all-knowing. Okay, so all that so far is consistent. You've got all these prophets or writers or theologians or whatever throughout history, and I'm only mentioning 6 here, probably some of the most prominent in the Western world. But this has been a subject that's been debated for centuries, over and over and over again. There's been fights over this issue. There's been excommunications. There's been burning at the stake. There's been a whole lot of stuff over this issue. So it's been an issue that's been around for hundreds and hundreds of years. Do we have an answer today to this issue, this simple issue? And it turns out that the mathematicians do have an answer, and that is they ended up with all, like all the others, they ended up with both. They were able to figure out a way to cover all the bases. You have free will, and your future is already predestined. We know exactly what's going to happen. God knows, at least, or someone knows. The universe already exists out there, and all you're doing is walking into footsteps. So it's both. And you try to figure out if you can reconcile those two notions. Okay? Yeah, it's one of the things that debunks traditional religions. That's essentially what it comes down to. Okay, so we start with this gentleman. His name is Pierre Laplace, French guy, days of Napoleon. And he suggested that if we knew, he was a physicist, mathematician, etc., right? And he calculated, he said, if we knew how the position of every particle, the location and where it's moving and what it's doing, etc., we could predict the future because it would be a mechanistic universe. We would know where that particle is going to be, where that particle is going to go next. So he says, we may regard the present state of the universe as the effect of its past and the cause of its future. An intellect, which at a certain moment would know all forces that set nature in motion. He's talking about God, even though he didn't believe in God. He didn't he was an atheist, okay? And all positions of all items of which nature is composed, if this intellect, okay, were also vast enough to submit these data to analysis, it would embrace in a single formula the movements of the greatest bodies of the universe and those of the tiniest atom. For such an intellect, nothing would be uncertain, and the future, just like the past, would be present before its eyes. He described the block universe, essentially. He says, look, if there is such a thing as knowing all the positions and locations and movements of every little particle in the universe, if there is such a computer, such a mind, such a God, all-knowing God, right? Then the future could be predicted because we would know exactly how that particle is going to move next, and the other one, the other one, the other one, all of them. And so we could predict exactly what's going to happen in the future. There would be no uncertainty. Okay? And so he's saying that, and remember, he's a guy who was an atheist. He didn't believe that there was a God out there. Napoleon asked them once, what about God? And he answered, I have no need of that hypothesis. Okay, it turns out that this is what 200 years later we have Mr. Al-Khalili say exactly. This individual, he vouches for the block universe. Okay, and he says, if we could know the position and state of motion of all bits, the building blocks of the universe, we know all the forces between all the particles, the atoms and the particles that make up all the atoms. If we knew what everything was doing and where everything was in the universe at a given moment in time, then this view of time that we inherited from Newton, okay, clockwork universe, right, tells us that in principle we should be able to compute how the future would evolve. That's what I mean by deterministic universe, the Newtonian clockwork universe. Okay, so it's a mechanistic universe that he's describing here. He says, if we knew all this, well, then it's just like Laplace said. All you do is just compute what every particle is going to be doing for the next, series of, for the next time, amount of time, and then you can predict the future perfectly. And if you can predict the future, the question is, are you just predicting, or does that future already exist out there, and are you just following the footsteps of a pre-programmed script? Okay, that's going to be the issue. He says, since our bodies, our brains are made of atoms, particles, physical entities subject to the same laws of nature as anything else, then in principle, knowing the future means knowing what our actions will be in the future. So determinism tends to suggest that the future is preordained, that we have no free will. Okay? Now, one question a lot of people ask is whether living entities, which especially animals. You know, they have the ability to take decisions and go left instead of right at the last moment, whether that's part of this mechanistic universe. Okay, and that's what keeps people from arriving at a solution, sometimes personal, belief or whatever, of whether this is true or not. They say, well, if you talk about asteroids going around, the sun, and that sounds mechanical. But humans at least, if not other animals as well, they don't function exactly so mechanically. They kind of take decisions at the last moment, go this way instead of that way, and the question is whether that's predictable and whether that can fit within these descriptions. Okay, so that's going to be in the background for those of you who believe that it is possible to have determinism and free will at the same time. Okay, Al-Khalili continues, and he says the following. He says, in Newtonian mechanics, we have the idea that fixing the initial conditions, say, in a game of pool, we will be able to compute how the future will evolve, okay? We can never know in infinite accuracy exactly where every ball is so that we can crank the handle. The equations to work out what's happening in the future, because the slightest change in temperature or humidity or a grain of dust somewhere would eventually magnify and alter the future. Okay, so any little variable there can change the whole thing. Okay, this is called the butterfly effect, and it's part of something they call chaos theory, but it doesn't rule out this notion of determinism that in principle, were we able to know, then the future is fixed. And this is what he's referring to. He's referring to something like this, where known as a butterfly effect, where if you have this little pendulum, and it depends on its starting condition there, right? That's what it's going to draw, because you can calculate each one of its motions after that. If you start at a different point, and if you have some other variables come in there and mess up your calculations, then it won't have this smooth or these curves. It would have a different type of motion and a different type of drawing and different type of pattern. That's what you would come up with. Okay. Okay. So Al-Khalili says, well, Newton was doing fine, but then Einstein comes around. He just reinforces Newton. He takes it one step further. He said the Newtonian universe was compounded by the turn of the 20th century when Einstein developed his theories of relativity. Relativity leads to this notion of what's called the block universe. Okay? And so now we're going into something a little dangerous, because not only does Newton and Laplace say, look, if we knew all these particles, where they're moving, where they're at, and how they're moving, what direction, all this kind of information, we could predict the universe. Now Einstein says, hey, don't worry about calculating all that. The future already exists. There is this block universe, and the future has already happened. The future is the past. For whom? Maybe for God, I don't know. But this is the notion that they have in general relativity, that you have this big loaf of bread, as Brian Greene illustrated. That was the analogy he used. And he says, if any slice, very thin slice across that loaf of bread, that's one bit of time. You make it as thick as you want. You want to make it a 1 second, a microsecond, a nanosecond. Make it as thin as you want. Okay? But he says, the universe is made of all these slices of time. Okay? This is the notion they have in the whole. All these slices form this big bread called the block universe. Okay, that's where they're headed with with this idea. Okay, and here's what he's referring to. That's the block universe. I always think of it as a as a little glass that just fell over and all the beer came out. Okay. God's probably astonished to see that. He's probably freaking out. Okay. And here we have the block universe that he's referring to, something more or less like this. He describes it. He says the block universe is a 3D block meant to signify the whole universe, the whole of space. But space is just this flat surface. See there, it's just a two-dimensional flat surface, space, on the picture on the right. Okay, time, on the other hand, has this linear direction toward from left to right, but space is only 2D. Okay, it's flat. And he says we've thrown away the third dimension because then I can use it as a time axis. No kidding. He can't picture this thing. He can't put 3 dimensions of space and 1 of time because they would not be perpendicular to each other as required by the notion of dimension. And so he artificially, by brute force, he just chops one of the dimensions out. And he said, I'm just going to leave 2 dimensions. And this, he says, well, let's say here, imagine a cross-section through this universe, which is our now. Behind now is the past, in front of us is the future, and a point on the now is our here and now. Okay, and he says this is a very useful way of solving problems in physics. Well, I don't know about physics. Looks like he's talking about mathematics, because this has nothing to do with physics, and the fact that he got rid of 1 dimension shows that he's not going to be dealing with 3-dimensional entities, which is what we have in our universe. I don't know of any 2-dimensional planes floating around, but this is what they're going to do because they can't imagine their 3rd dimension in this scheme of things, and so they have to get rid of 1 of the dimensions. Okay, so that's how they do it. They're going to get rid of 1 of the dimensions. Does that make sense to you? Instead of a cube, they're going to be dealing with squares. Instead of a sphere, they're going to be dealing with circles, etc., etc. Okay. Let's see where they want to take us with this. And so he says the following. He says, what it suggests is something even more dramatic, even more bleak than Newton's clockwork universe. Ooh. In Newton's universe, the future is fixed and preordained. Fate, as it were, but it hasn't happened yet, even if we could predict what would unfold. Listen what he's saying. He's saying it hasn't happened yet. But that's not what the block universe tells us. The block universe tells us that it has happened, and we're looking at the past from a farther past. You're farther past from the past. So he's saying it hasn't happened yet. Okay, it's getting scary, but it's going to get scarier, I think. Okay, let's find out where this takes us. In Einstein's universe, the future is just as real as the past. Well, if it has, we have a problem. It hasn't happened, but it's real, he says. He's got a contradiction right there and then. He says, it hasn't happened, but it's real. What does he mean by real? Well, they never define the word real. They never define what exist means, and so they can get away with murder. Okay? It says the future is just as real as the past. Everything is frozen and static. So it's already there. It's a picture. You're moving into a picture. If you saw, maybe I should have put that in there. If you saw Mary Poppins, you see how Bert and Mary Poppins, they jump into a picture. And that's more or less what these people are saying, that you can jump into a picture and you become part of that picture and whatever is going on in that picture. This is the view that God has. Yeah. So we're talking here about God, yeah. They have to introduce the word God in there. He doesn't like the word God. He claims to be an atheist or whatever. But yeah, they have to introduce God here because we're going to go into what we know and how we know it. And that's God. You know, if God knows everything, God knows the future, we become God, so to speak. You know, suddenly we can predict the future. We talk about knowing the future, right? That's what these people are talking about. So they're trying to become like gods, or they think they are gods. I don't know. Does this really mean that the future is there? Well, he just said it's real. It's as real as the past, so it better be there, right? That it's happening? No, we're saying that it happened, not that it's happening. It's already finished. It's done. That's what he said. It's real. And he said it's static, frozen, static, real. What is he talking about? He's saying it's there. And now he's saying that it's happening, that our present moment is no more special than any moment in the past, any moment in the future. This has nothing to do with whether a moment is special or not special. Now he's drifted off into a tangent. He doesn't have to introduce this notion of special, whether we're special here in the present or in the future. The issue here is that he's saying that, does this really mean the future is there? And it better be there, because he says it's real and it's frozen and it's static. And he's talking about a block universe. What is he talking about? He's talking about that time already has completed. We're already, in other words, the big crunch has already happened. Big Bang to Big Crunch, that's what, gazillion years? The gazillion years are over. The whole time block is finished. It's all done with. It's there. It's a picture. It's static. All we're doing is walking through there. And if you can go to the future, well, you should find something as real as in the past. Something as static, that you land somewhere, right? Somewhere and somewhen. It's not really necessary to view all the future as fixed in this deterministic way. Yeah, because it kind of destroys your free will. And so you got to leave some hope for people saying, oh, you mean my future is already determined, why should I worry? You know, if I rob the bank, I can tell the judge, you know, it wasn't my fault, it's God that programmed me that way. The judge said, yeah, he programmed me to put you in prison. It does suggest that the future is predetermined, but it's not the whole story. Okay, so he's going to make a little loophole here. He's going to go on a tangent to try to save his argument. Okay, that's where he's going, and that's where all relativists typically go, right? What is he going to do? Well, he's going to go into the twin paradox. He's going to use that as proof, as evidence, saying that, oh, we've proven the twin paradox, and now I'm going to synthesize it for you so that you can see why we have reason to believe all this. And he talks about Alice and Bob. You know, Alice goes on a trip. She goes. She can go to the future. She can go anywhere. In fact, we had her last week, and she went on a trip, faraway trip. Came back. She went close to the speed of light. When she comes back, she's got the same. She's got a different age than her twin brother Bob, who stayed on Earth. He aged maybe 50 years, and she aged only 1 year. And this is a calculation that I've shown last week that mathematicians do, and they say this proves that it's true, and then they prove this supposedly with an experiment, right? That it's true that time does dilate when you're traveling at close to the speed of light. And one of the issues there with this time dilation that you have to keep in mind is what I keep saying, you know, and here Al-Khalili also was asked that question, and that's, you know, how many times did the Earth go around the sun? And the Earth goes around the sun once a year, 365 days. And so when the question is, how many times did the Earth go around the sun when Alice went out and came back? And Al-Khalili, you know, didn't answer that question. He answered a question that he wasn't supposed to answer. He said, well, from Alice's point of view, the Earth is traveling at a different speed. Well, we don't care about that. We care when Alice comes back and meets her brother again. They're both on Earth back again. How many times has the Earth gone around the sun? Has it gone 50 times or 1 time? That's an objective criterion. You know, when she's back, we got to look at the calendar and say, how many times did the Earth go around the sun? Well, it went 50 times. And here's the calendar. You left in the year 2000, came back in the year 2050. 50 times have gone around the sun. That's 50 orbits. And she might say, well, you know, my atomic clock says something different. Well, I don't care what your stupid atomic clock says. You know, the question is, how many times did the Earth go around the sun? And that's objective. And we don't care what your atomic clock said. We don't care how fast you went out there to the black hole and around and back. We don't care about any of that. When you come back and meet your brother, if you say that he's 50 years older than you, well, you got a problem, because you got to justify that. You got to say, well, how many years does he have? Well, he has 50 years. You better have 50 years as well, because that's how many times the Earth went around the sun. And if you only go to Mars and back, you know, again, traveling at the speed of light around Mars and then come back, we got the same situation. You can't, so you don't have to use a faraway black hole. You can use it to Mars or something close by here in the solar system. Come back. Well, hopefully, you know, I don't care how many times you went around Mars. Mars travels at the same speed as, or more or less, you know, slower, half the speed that Earth goes around the sun. I think it's 656 Earth days or something along that line to go around the sun. So the Earth goes maybe 2 times while Mars goes once. And so she can go around Mars as fast as she wants, close to the speed of light, then come back to Earth. Hopefully, the number of times Mars went around the sun matches more or less, the 2-to-1 ratio between the Earth and Mars. Okay, so it doesn't matter how fast she goes around Mars. Okay. Anyways, he introduces the twin paradox, and he goes in there and he says the following. He says, time travel into the future is possible. He's going to use this Alice and Bob analogy, twin paradox, they're twins. But it doesn't necessarily mean that the future is out there waiting for Alice. Then what is waiting for her? What is she landing on when she lands on Earth? Or, where does she land? Is she going to land in Mars? The same thing, Earth and Mars travel around the solar system. There had better be a relationship there between Mars and the Earth. Okay, can't be that she suffered so much difference in her time than her brother on Earth. Okay, that the future has already unfolded and she's getting to that future. All that's happening here is that she's moving out of Bob and Earth time frame and fast forwarding into the future. She's getting to the future before everyone else. He doesn't say she's getting to Earth 50 years in the future. He doesn't say she's getting to 50 years in Mars in the future. He's saying she's getting to the future. Future is a concept. You don't get to the future. Tell me where she got physically. Where did she land her feet? In a jungle, in a desert? I need to find out where she landed. What does this future thingy what is it? Okay, that's what he's got to answer. He doesn't answer that. He goes to concepts. Says she went to the future. Oh, where is it? Please draw it for me. I want to know what the future looks like. Okay? And she's getting to the future before everyone else. Less time has gone by for her. Yeah, when I sleep, I have dreams, or maybe if I drink too much booze, then time also dilates for me. What does that mean? It's personal opinion. Just look at the calendar and you'll sober up again. Okay, her time really has slowed down. She really has time traveled into the future. Again, into the future. He doesn't say time traveled to Mars or to the Earth in 2,000 years further on. When you see Marty and Back to the Future, he always lands somewhere, okay? And that's what I want to see these guys talk about, the mathematician. Where do you land? Give me a specific, place. Are you landing on Earth? Are you landing in Africa on Earth? Are you landing in the year 2050 for Africa on Earth? Where are you landing? This is not just some theory someone has come up with. We know this happened. There's the authority. He doesn't explain it, but we know it. We proved it. You better believe it. All you can do is memorize it like he did, okay? Because otherwise he wouldn't get his degree, okay? It's been proving time and time again. Yeah. This is how they do it. They just tell you it is so. Okay, and but the way we do it in science, we look at how many years went by, and a year is just one revolution of the Earth around the sun. And hopefully when Alice comes back, she just looks at the calendar and can tell very easily, without her atomic clock, how many times the Earth went around the sun. So this is a very easy issue to solve. Okay, it shouldn't take any mathematician to resolve this. Just count, if you're a elementary school kid, you can count how many times went around the sun. Just look at the calendar. You'll know if it's went 2, 3, 4, 5 years. You don't need to be a rocket scientist for this. Okay, so here we have what they're referring to. This is the block universe, and you have all these slices of time. Okay, you can think of those as thin as you want. Okay, so let's do a little time travel. Let's say you wanted to go back to the past. I've chosen a date. I'm going to choose the year 800, the days of Charlemagne, for those of you who heard about him, read history, okay? And Charlemagne lived around 800 AD, okay? Almost 1,200 years ago or so. we're going to go back in time, okay? We're going to go to that slice that is 800, in the year 800, okay? Now, when you go back, if what these people are saying is it's true that you can go back in time, let's assume that for a second, well, then what would you see? Well, you would see Charlemagne. You would shake his hand. You would land in France or, in Aachen in Germany, one of those places. You would end somewhere in Central Europe, and maybe you end up in a battle, or somewhere, or maybe in his palace. So you would see the people in those days. What would that mean? Well, it would mean that you would have that situation I explained the other day, okay, where you went back. In this example, I have the year 0, but it's the same concept. If you went back to the year 0 or the year 800, anytime in the past, the Earth, the entire solar system would be somewhere in the universe where it's not today. So every galaxy, every star in the universe moved to a different location. And what these people are saying, that when you go back in time, you go to a time where the solar system is at a certain location, not only with respect to today, but with respect to every other star and planet and asteroid and atom that was, there 2,000 years ago. Is this possible? Can you move to the Earth to see Charlemagne or to see Jesus Christ, for example, in this case, 2,000 years ago, where all the stars and galaxy and everything moved backwards to that file, to that file in your file cabinet, to God's file or God's file in his computer? Is this possible? Does this make sense that the entire universe moved backward, or that there is such a file that you just go in there and land on? A three-dimensional file that's got time on one of its axes that we can't imagine? Yeah, so this is the problem. So what is the problem when going forward? Well, when you go forward, here you go to the year 2100. You're in the year 2020, and now you're going to move to the year 2100. Where do you land? What are you going to see? Are you going to see your great-grandkids? Is this what... are you going to land in whatever country you live in, and you're going to see your great-grandsons or whatever? Is there something there? But he says it hasn't happened yet. And if it hasn't happened yet, where are you going to land? I mean, what are we talking about here? Is there a file or not? That's the only issue. Is there a file in God's computer that you can land on, that you can say, okay, this is the year 2100? Is there such a file? Does God move every little atom in the universe to the location where it will be in the year 2100? And if so, it's already happened. That means that we know, if we know everything that's going to happen from the year 2020 to the year 2100, then that means that you have no free will, because all those files already exist. And all you're doing is just walking through the motions. You're walking through the footsteps that are already there. So they haven't solved the problem. And this is the problem that really destroys traditional religion, the notion of an omniscient God, because you can't reconcile an omniscient God that knows everything, knows the future, knows what you're going to be doing, knows whether you've been predestined to go to heaven or to hell. You cannot have that on the one hand and free will on the other. You simply can't. And they go through all these, all these philosophical arguments trying to reconcile and cover all the, reconcile the two and cover all the bases. That's what they've been trying to do forever. And the mathematicians are no different. Quantum mechanics tries to reconcile general relativity on this issue. And whereas general relativity says your future is already predetermined because there's this block universe, all you can do is just walk the path that already exists, even though Al-Khalili then gives a qualifier, says it hasn't happened yet, which I don't know what that means. You got a tremendous contradiction there. But then we have quantum mechanics comes in there and say, we have uncertainty, indeterminacy. And so that saves the day. And that's where Al-Khalili goes next. He goes in there and he says, look, Fortunately, we have quantum mechanics. And determinism, the idea of the future being predetermined and preordained because of relativity, got a bit of a wake-up call in the 1920s, quantum mechanics. Whereas general relativity describes the whole universe, how gravity affects the nature of space and time itself. Quantum mechanics is the theory of the very tiny, the theory of the subatomic world, which I don't know what has to do with you, who are a macro object going to the future. The fact that maybe there is some uncertainty, let's even concede that. There's uncertainty in the atoms in your body that you can't know the position, the location, the momentum and within for that particle within your body. What's that got to do with your body, your entire body, moving to the future on this block universe? But that's what they're going to say. There's uncertainty at the atomic level, so we saved indeterminacy. Otherwise, you wouldn't have free will. And he says, and it's much weirder than relativity, no kidding. It has to do with cats in boxes being dead and alive at the same time, skier going through both sides of the tree at the same time. Is this something you're going to put your life on the line for? If they tell you, if the devil comes to you and says, look, do you believe in this or not? Your life is on the line. Which way you want to go? I mean, would you really believe that, that particle can be at two places at once, cat can be alive and dead at the same time, skier can go through both sides of the tree at the same time? That's what things down at the quantum level really do. And no one has a common sense way of explaining how that happens. Yeah, because you're doing it with particles. That's why. And you can't do the invisible world of Mother Nature with particles. They haven't discovered that in the last 2,000 plus years. That's the issue. We have to get rid of the particle hypothesis. You cannot simulate any of Mother Nature's invisible phenomena with particles. That's the problem. And yeah, if you try to do it with particles, it's unimaginable and you cannot put it on the screen for us. And you have to invent all this garbage, this nonsense that these people have invented, at least in the last 100 years. Okay? Okay, so what does he conclude? He says, quantum mechanics rescues us from this bleak determinism because down at the level of atomic, of atoms, it's subject to the laws of chance and probability. Again, what does an atom have to do with you moving to the future on the block universe? Okay, the fact that there's indeterminacy or uncertainty, assuming that's true, right? At the quantum level, what's that got to do with macro objects like you traveling? Statistically, if we have trillions and trillions of atoms, we can work out something called their half-life. Yeah, it's like the buffaloes. You have tons of buffaloes. Each buffalo has free will, but they all, go with a herd and they all fall from the cliff. And you can say, well, that's predictable. Yeah, maybe, One buffalo might go to the left and decide not to fall from the cliff. I don't know. Maybe they all fall from the cliff because they just follow along, like Al-Khalili follows, his predecessors. Buffalo going down the precipice. Says, how long does it take before the half atoms are going to spit out alpha particles and decay? Talking about uranium, spontaneously pushing out particles. But you look at one individual atom and you can't tell. Yeah, individual atoms, they might have a problem analyzing that. That's not an issue. The issue is, what does that have to do with a macro object like you going to the future? Because nature herself hasn't decided yet when this is going to happen. And that's the argument he introduces to say, fortunately we do have free will, because at the quantum level, atoms are unpredictable. We cannot tell you what their next location is, what their next position is, especially of the electron, right, around the atom. And because of that, that saves indeterminacy, which is a synonym, essentially, of free will. And they say, fortunately, we have free will, and we also have determinism, because you got to study general relativity for that. And right now we're doing quantum mechanics, so don't worry about that. So we have both, okay? And so he concludes, that's his closing argument here. And he says, quantum mechanics gives us back indeterminism. So our future is not decided. Nature hasn't decided what's going to happen next. That means the future is open. It means we've rescued free will. We are responsible for our actions. Okay, so sorry guys, if you thought that you were going to rob the bank and tell the judge that, hey, quantum mechanics says that I have free will, but, general relativity says, it was all preordained that I would rob the bank. And again, the judge says, yeah, and I was preordained to send you to prison. So do we have free will? Or is everything, are you a puppet? Are you a little cartoon character in a pre-scripted movie, video, or cartoon strip? Both. You have to do what the scriptwriter told you to do if you're Bugs Bunny, but Bugs Bunny can jump out of his script and do whatever he wants also, because that's allowed for by the laws of quantum mechanics. How's that for an analysis? Okay, I hope you can sleep well tonight.